Hello, I am Bandit Tin Kamrop. I work at the Department of Epidemiology and Biostatistics at the Faculty of Public Health, Khon Kaen University, Thailand. I made a series of videos for biostatistics. I call it Overview Biostatistics. And I try to make the students who will join my class to have some idea, some concept in statistics, so that when we meet in the class, we talk the same language. Most of my students is aim for doing a research. The graduate students, that means at least they will conduct a research for their thesis. So it's not aim for a statistician, but more in for general students or general people. This is an episode 1 of my lecture. So for this episode, I will introduce you to a very important concept. The research workflow where I display the role of statistics in research. And I start with begin at the conclusions is the key success in applying statistics in research and in understanding statistics. Research here, I mean quantitative research, which need to quantify things. Quantify what? Quantify the magnitude. Quantify the magnitude of effect, I would say, that being used as the basis for a conclusions of the research. And this is the main thing that I call begin at the conclusions. That means the body of the knowledge that will apply to the populations in general. So what we found in the study, which is from a small sample, will be inference or generalized to general larger groups called populations designated by capital N. That means we need to study not from every individual in the population, but from a subset of the populations, which is called the sample or small n. So this arrow is the sampling methods or sample selection to get the sample, and how large is the sample in statistics is called sample size estimation or sample size calculations. So up to here we have 3 steps already. The first one is the conclusions in the paper. Either we are a researcher, we need to conclude something to be a take-home message for the reader, for the audience. Or if we are a consumer of the research, mean we read a paper, we will cite that paper based on what they found or they concluded. That's the number 1. And number 1, knowledge is usually universal. That means from the sample applied to the populations is number 2. What is the populations that this knowledge can be applied? And usually we have the sampling frame that we can touch, or the list of all populations, and we draw samples with some certain sample size. So number 3 is in statistics. There is sections in a paper, research paper, about sample size calculation. And then from that, we need to measure or collect the data. So we will have a data collection form. It could be N set of questionnaire, for example, or case record form, or CRF. So that's number 4 is the tools to collect the data. And then we transcribe the data being collected in that forms to a database. So look like a spreadsheet where the header is the list of variables. And each row of that spreadsheet is a record. All record from the first record to the last one, N, is called the data. So there are variable and data. And this usually be imported into a statistical package to analyze with a purpose. A purpose that aim to answer a research question and end up with a conclusion, number 1. So up to here, we need to understand about the data being collected, that what are the 2 components of the data. The first one is what are the variable, that is the outcome, or the dependent variable designated by Y. And what are the independent variables or explanatory variable designated by X. And then after that, we need to be able to classify what is the type of that variables. There are types of variables, but I put it here just a common one. We will cover it in the future slide. If, for example, if it is a continuous outcome, like birth weight or the weight, we will have some guideline to go for what statistical method. If the outcome is categorical, like cured or not cured, dead or alive, we go for some guideline for statistical method. Also, for the independent variable X, if we identify type of the variables, we then knows what we will use, what statistical method will be used. So that means it's really important to understand from the beginning, which is the conclusions or the end, until the last step about the variables being collected to get that and type of it, so that we can know what statistical method is appropriate for this research. And then From this, number 7, statistics will quantify, and here only this flow. Quantify what? Quantify random error that make the magnitude that being used as the basis for these conclusions that is unclear, or make the noise large or small. So we need to understand about this magnitude being quantified for this conclusion, that it comprises two components. It could be truth plus some noise. It's unavoidable, there is some noise, because everything is unstable, is variable. So this noise, if it's large, that means that conclusions is not valid. Large or small could be because of bias or systematic error, or it could be just random error because it's varied widely from person to person, so it's difficult to conclude. This one is the nature of things. We can just quantify it for judgment. But the bias is something that being introduced by how we do a research based on a study design. So that means our role is to reduce or prevent the bias to occur by design the study well and conduct the study in the way that there is no bias. So the noise caused by the two components, where the first one is the systematic error or bias, we need to control it or minimize it or prevent it. But random error is the nature. Things are vary. We just quantify it. So this is the first episode of my lectures that I like to introduce to you. We will continue to the second episode about how statistics could play roles in these quantifications.